Hello guys, this is Mustafa and today we will discuss about the 4:1 multiplexer. I already told you about the introduction and the 2:1 marks. Now we will discuss about the 4:1 multiplexer. As its name indicates that 4:1 multiplexer, it has 4 inputs and 1 output. It's also the combination logic circuit which is widely used in the digital design, and it routes a particular input to the output depending on the select variable. This select variable plays an important role in routing the particular input to the output. Now you can easily determine the number of select lines in 4:1 mux equal to 2, as the diagram indicates that it has 2 select variables. I will tell you that how to calculate the select variables. Now for 4:1 mux, you can easily calculate the number of select variables by using the formula m is equivalent to log to n, as you calculated in 2:1 mux, or 8:1, or 16:1, or 32:1 mux. Here m is the number of select variables and n is the number of inputs. As the number of inputs in the 4:1 mux is 4, so simply put 4 here in place of n. So I write this m is equivalent to log 2 to raised power 2. I just replace 4 by 2 raised power 2, which is equivalent to 4. So according to the logarithmic formula, log m raised power n is equivalent to n log m. So I put it here. So 2 log 2 to the base 2 is equivalent to 1. So 2 into 1 is 2. So the number of the select line in 4:1 multiplexer is 2. So now coming to the truth table of the 4:1 mux. Here it is select variable 1 and select variable 0 and y. It is one select variable number 2 and output y. And depending on these combination of the select variables, the particular input will be routed to the output. Here y is the output and I is the input. So I assume that when both the select variables are 0, the I1 is routed to the output. When select variable S1 and is equal to 0 and S0 is equal to 1, the input I1 will be routed to the output. Similarly, in those two cases, I consider a particular combination for I2 and I3. Now on the basis of this two table, you can easily calculate the equation for the output y. When there is 0, you represent it by bar for complement. When there is 1, you represent it by simple variable. For example, just take the example of this first combination when both S1 and S0 is equivalent to 0. Here you represent it by S1 bar, S0 bar into I0. In second combination, you represent it by S1 bar, S0 and I1. In third, you represent it by S1 because it is 1 here, and S0 bar because it is 0, and I2. In last combination, both are 1, so you can represent it by simple variable S1, S0 and I3, and the output will be the combination of the whole terms, that is y is equivalent to S1 bar, S0 bar, I1, that is S0 bar, S1 bar and I0. Second will be S1 bar, S0 and I1, that is S1 bar, S0. Similarly, these terms will come out. Okay. Now coming to the logic diagram of this 4:1 multiplexer, you can easily calculate, or you can say these equations on the base of truth table. Now on the base of this truth table, you can easily draw the circuit diagram or the logic diagram of the 4 is to 1 multiplexer. When there is bar, S1 bar, you represent it by NOT gate. When there is a multiplication term, you represent it by AND. As you all know that the AND is used for the multiplication AND gate, I mean to say. And when there is a plus term or plus sign, you can represent it by OR gate. That is, this will be your logic diagram. Whole logic diagram. These are the inputs. These are selective variables. Here this NOT gate will indicate the bar, and this simple line will represent it by simple variable without bar. And this is your output Y. Here I represented by sub 1. So this is all about the 4:1 multiplexer. See you in the next one. Thank you.